What's going on, guys? So I wanted to make a video going over subwoofers. I wanted to try to give a rundown of how they work and what they're about and what to look at when you're thinking about running certain subs, what you may or may not want, what you may or may not need, what all these different specs mean. So I feel like most people, when they look at a sub, they look at things like the power handling rating, and they'll judge a sub off of how much power it can handle. And for example, the W3 12-inch there is, if you look online, it's rated for 500 RMS. If you look on, say, the JL website, they show between 250 is a sweet spot to 500. That's because you don't have to run a sub on full rated power for it to sound good. That'll play into the box. I feel like today, in today's world, people feel like they have to run double rated power to a sub or something to make it sound really good. If your box isn't on point and you have to push a sub that hard to get full potential of it, then maybe you do have to run that much power. But if your box is on point, you don't have to. What you're going to do is you're going to send more current, more heat, more stress through that sub, which can lead things to failure sooner, cause things to get hot, burn up a tensile lead, burn up a voice coil, blow a sub. And at that point, it's not the sub's fault, it's not the manufacturer's fault. I mean, things fail when they get pushed beyond their means. So people look at subs based on power. And I feel like people who are newer, maybe people who aren't newer, look at a sub and say, well, this sub's rated at 1500 RMS. This sub is 2500 RMS. So this one that's at 2500, it's going to be louder. It's going to give me more bass. It's going to give me more output. No. Yes and no. If you have the amplifier and the power on hand and then the electrical to back up that amplifier to properly push the stronger rated sub, then yes, potentially, because then you're running more current through that sub. If you really can't push any more than, say, 1500 RMS cleanly and safely, you could maybe benefit from that little bit higher rated sub, and I'll explain why in a second, but you're better off running a sub that you can properly power. And there's a couple reasons for that. All right, so looking at these subs here, this is an SA15. This is a JL 12-inch W3. So obviously, first glance, you're looking at bigger sub, more tone area. But when you talk about a sub, you also talk about displacement. Displacement is going to be cone area, which we all look at. 15-inch sub, 12-inch sub, easy. But also you have to look at excursion. How far are these subs going to travel? And so that's why some 15s will work in a 3 cubic foot box. Some 15s will work in as large as 5 cubic foot. And that has to do with the displacement of that driver, because it might have a lot more excursion. So it's traveling a lot further, so then it can actually take a larger box to still support that sub. But also it's going to play into the spider, just how soft and or stiff that spider is, and also the size of the motor, which plays into the motor strength. If you have a sub that has a very strong motor force and a soft spider, it's going to call for a smaller enclosure. If you have a sub that has a lot stiffer spider and it's going to make it harder for it to move, then that sub can thus work in a larger enclosure or handle more power, because either you're going to have less air support inside of that enclosure to help it move easier, and the spider is going to help handle that sub, or you're going to run more power through this sub to thus counteract against that stiffer spider. That's what it's there for, is for, say, an SPL setup, so that way you're running the most power that you possibly can safely through that coil, and the spider is going to hold it. That's why people run, you know, triple and quadruple spiders and stiffer spiders, is so that way it can handle more power, because you want to run the right kind of enclosure, which goes into box rise. Someone asked on the page about that. I'm going to get into in a second. But so your box that the sub calls for is going to be about how much excursion the sub has. Obviously, the size, the cone area of the sub. It's going to play into the spider. Is it soft? Is it stiff? Motor force, and then how much power that you're giving that sub. So most people will look at a sub, and first off, like I said, look at power rating. Secondly, they're going to look at the size of the motor and say, oh, wow, you know, that's got a huge magnet on it, you know. And that's why a lot of companies will put a lot of plastic around the motor assembly and all that stuff to make it appear and look beefier and stronger than it really is, because people visually choose their subs off of how it looks. So the reason why your magnet is bigger plays into how your subs work. And, you know, just like this is a smaller sub, less power rating, so obviously it's got a smaller motor on it than the SA line does. And that comes down to power handling, and also will play into motor strength. You run a larger magnet here, because that's what this is a magnet. Either ferrite, which is what these are, or you have neodymium. And the magnet is going to have a grade, and so is the neodymium. You know, there's going to be different levels of grade, which is basically quality, how strong, how good is that magnet. And so this is going to be a fixed magnetic field. Now, your coil is going to pass through that magnetic field. And so when you have an amplifier, and you hook up your sub to it, and this amplifier creates AC current. Say that I had this W3 12-inch bridged at 4 ohm on this 2-channel here, and it's seeing rated power. Yeah, this amp is going to be sending AC current to the sub, and a plus and a minus, and of course that's alternating current, which means it goes plus minus. That's why your sub moves back and forth. And so how much current you're putting out of the amplifier in relation to how much power you're giving to your sub is going to play into how much force is going to be going through that sub, which is going to affect just how far it moves back and forth. You know, when you have your volume, and, you know, of course, make sure your gain set correctly. Gain is in volume. But your volume knob on your head unit or your phone, whatever, and then you turn that signal down, it's going to reduce, which means that your sub's going to move less. Turn it up to a higher wave, a lot more amplitude, amplitude, it's going to cause it to move back and forth more. Now, that is how it reacts outside of the box. When you actually place your sub inside of an enclosure, the enclosure is now supporting that sub, as well as the spider, as well as the motor strength, as well as the surround. Everything's working together in unison. And so based on the sub, its spider, its motor strength, the power it's seeing, all that is going to go into consideration when you design your enclosure. Now, a lot of people look at a sub and they wonder, they don't feel like they're getting the full potential unless the sub's just going peak to peak. You know, it's just wanging out, just boom, boom, boom. Your sub will actually move less at and around tuning, which means that if you are tuned at 32 hertz, and you know for sure you're tuned at 32 hertz, your sub's going to move less at 32 hertz. And so once you get below tuning and above tuning, the sub will then start to actually have more excursion. It'll have less at and around tuning, which plays into the question of box rise. If you're playing, box rise is impedance rise. When your sub plays and it moves back and forth, the coil passes through that gap. back and forth as it's playing, the impedance of your sub is constantly changing. And if you know anything about amplifiers, how they work, the impedance, the resistance that you're showing this voltage that's coming out of your amplifier is going to thus predict and determine how much true power your sub is seeing. So as impedance goes up, it's going to see less and less power from your amplifier. Now, when you're playing music and that sub's going back and forth, the impedance is not constant. It's constantly changing. It's going up and down, up and down. So to combat that, you're talking about primarily SPL goals. So if you want it to do a burnt box and you want it to peak at a certain frequency and get as loud as possible, you want to design an enclosure that, if you know your car peaks at 45 hertz, you want to design an enclosure that is also going to peak at 45 hertz. And at that moment, because of the enclosure, it's going to help your sub move least at the peak frequency of the enclosure and of your car. And by keeping it moving as little as possible, it's going to have less rise and thus keep more power out of your amplifier. Now, if you're playing music, like most people are, how do you combat that? Well, if you look at where I've graphed in the past and tried to explain the importance of an efficient enclosure, where I've graphed subs and stuff in the previous videos, if you're worried about losing output because of impedance rise, power dropping or whatever as you're playing, I've tried to, and I hope I've done a good job of showing how that you can actually gain more output from your box rather than just running more power. So if you want to help combat that in a daily system, run a really efficient enclosure. What I mean by that is run something that is going to make good use of your space, that is going to best meet your goals, that is going to let you get the full potential out of your sub. You run an enclosure that is going to fit in your vehicle well. It's going to meet your needs, meet your goals, and if your enclosure is efficient, sounds good, it's hitting all the bases for you, impedance rise should not be a problem for you, because your enclosure is going to make the biggest difference in your output, how it's going to sound, how it's going to perform. That's how you combat that. In an SPL setup and scenario, you need to test. You need to know exactly where that sub is going to peak in your car, how it reacts in your vehicle, different testing. If you have your port loading off the rear, off the side, loading up, whatever, you need to test. That is application dependent, but your goal there is to have the sub move less at that peak frequency. That'll come into the box volume, port area. Typically an SPL setup where you're trying to do that burnt box at a good frequency, you're going to shrink volume, increase port area, and that's going to support the sub, but then gain that efficiency through that increased port area, and then you need to get the tuning just right. But that's going to sacrifice, of course, low-end response and bandwidth, but that's not what you're trying to do in an SPL burnt box. All right. So anyways, what you're doing is you're passing the AC current through that sub, and it's going to react. And the reason why is because coil here, and it's going to connect to your amplifier in a plus and a minus. If you have a single coil, like this sub here is a single 4-ohm voice coil. That means that is one coil. It goes in here, wraps around however many wounds that it has, comes back out, boom. Plus, minus to the amplifier. A dual voice coil means that you have two coils that are wrapped around each other, around the former. And so you'll have a connection over here and over there. Some amps have them side by side, whatever, but you still have two hookups and two voice coils. Now, why do you have that? So if you had a single voice coil here, then it's, this is 4 ohm, and that's just what it is. So when you have a dual voice coil and you got multiple hookups here, and say this is a dual 2, you can wire this up parallel to 1 ohm or in series to 4 ohm. Now, what does that mean? When you run parallel, you're running power through the coils together at the same time. So you're running both positive through both positive coils at the same time, and it's coming back out the negative coils at the same time. So these coils are getting energized and working together at the same time. And I'm going to explain that better in a second, but this potentially, and there's videos out there on YouTube that explain it better than I do, but this running parallel can actually give you an edge and an increased motor strength as far as output goes on a meter, because they're working together in unison. If you were to wire in series and you had a dual voice coil, what that means is that positive, positive, negative, negative, you're going to pass all the power through the one coil first and then through the other coil and back out, because you're going to run the positive and negative of this coil together, of each different coil, and then hook up to this positive, to this negative. So the power is going to come in the positive here, go all the way through that coil, come out, go through the other coil, and then out to the amplifier. And so that is series. And if you think about it, you're running all the power through one coil and then through the other, rather than all the power through both coils at the same time. That's why technically you can have increased motor strength. The reason why is because where I said the magnets are a fixed magnetic field, when you pass AC current through this really small copper wire here, or aluminum wire, because some subs have aluminum voice coils, some have copper. Real quick, what's the difference in that? So aluminum is going to heat up slower and cool down faster. Copper is going to heat up faster and cool down slower. Copper can be energized a lot easier, a lot quicker. It can be good on less power. Aluminum is going to be able to handle a little bit more stress. It's going to take a little bit more of full power to really make aluminum copper coil happy. And they're going to tend to be they can be a little bit more peaky. Now, that don't mean they sound bad though, because W6 and W7 subs run aluminum voice coils. Look it up. I prefer copper because, like I said, they just tend to give a little bit smoother response. They tend to do okay on lower levels of power. Because there again, just like the power wire in your car, copper is more efficient than aluminum. Plus, aluminum is going to also have a little bit less moving mass. It's going to weigh a little bit less than copper, which plays into moving mass of your sub, which is going to play into the cone area and the suspension and the surround. That's all your moving mass. Now something else I want to talk about. The SA15 here, Sundown, has a pulp paper cone. JL has a plastic cone. Well, it's not plastic, but it's that kind of material. It's going to sound different. W7s, if you ever listen to them, they have this same kind of cone material. They, to me, they provide a warmer bass. Maybe you like that. Maybe you want that. Maybe you don't. Paper, to me, has a harder, firmer bass. It gives you that really tight, hard-hitting, more solid, more punchy type bass. But, of course, your response is going to be all up to the box. Totally. But the material of the sub, what they're made of, is going to affect the moving mass, just how heavy this is. Is this going to weigh less than this? Is this going to weigh more? And it's going to affect the response curve and also the frequency response, the FS. All that's going to play into the cone material. That's why your SPL subs that have a lot of motor force will also run a very, very light Kevlar cone, because the cone is still very strong and very rigid, but it's also very light, which gives that motor that much more control over that cone. Because it's so light, it has a lot more control over it. Whereas a really heavy moving mass and a really heavy cone and sub, it's going to either take a larger motor to properly control that sub, or it's not going to do a very good job at running the sub and everything. So anyways, when you're running your current through this copper here, you have the magnet of the sub, and there's going to be a gap and a pole piece, and the coil is going to be inside of this gap. Now, so you're creating, when you pass power, AC power through this coil, you are generating an electromagnetic field. And so this field, as it changes polarity from that plus and minus, the sine wave, and it passes through this fixed magnetic field of your motor, be it neodymium or a ferrite motor, that's why it's reacting. And thus the amount of power, however strong your amplifier is, however high your volume is going to affect the reaction that it has in relation to this motor. So thus, if you have a larger motor, you're going to have more power going through that coil to react to that stronger field. If you ran a little power through a really strong motor, it's not going to move, or it's barely going to move. And that plays into design as far as heating goes. When your sub travels back and forth and your coil's passing through this gap, you've seen subs with holes and stuff in the motor and this and that, and then like around the vent hole there and all for air. That's how your sub cools itself off. That's how things stay cool, because as you're passing power through that coil, it's gonna, there's heat generated there. It's gonna get warm, and so the coil has to be the right gauge, the right size, the right strength, enough layers, all of that in relation to handle the current that's trying to go through it in relation to the motor. So there again, how I was talking about before, people will judge a sub off the size of the motor and all that. And so there is potential there to have more motor strength, but if you don't have enough power on tap to actually electrocharge and stimulate the coil enough to actually overcome all that motor strength, the sub is not going to perform as it intended. And actually, that's one way you can blow a sub, because if it's not moving correctly, and then this coil is going to heat up and heat up and heat up and get hotter and hotter and hotter because the air just is not going around the coil like it should be, it's going to finally fail. Either bust and unwind, or if you're clipping it, the leads can actually fray and come apart and burst and all that. So the motor is in relation to the amount of power that you're planning on running, and then thus they run the right kind of spider in relation to the motor strength and the surround and the moving mass and what it's meant to do. Is it meant to have a higher frequency response, be more of an SPL sub? Is it made to have a lot of excursion and made to play super duper low? Then it's probably got a softer spider. Now, so there's a gap. Now, like on FI or Phi, I'm sure you've heard of Phi, FI.